Can a cat be both alive and dead at the same time? A puzzling question, isn't it? This is the famous thought experiment proposed by physicist Erwin Schrödinger, a paradox that dives into the fascinating and perplexing world of quantum physics. Imagine, if you will, a world where an object can exist in multiple states simultaneously. A world where a cat could be both alive and dead until observed. This is the essence of Schrödinger's theory, a cornerstone of quantum mechanics. It's a concept that challenges our everyday understanding of reality, pushing the boundaries of what we consider possible. In the realm of the quantum, the laws that govern our physical world take a back seat. Here, particles can exist in two places at once, or spin in opposite directions simultaneously. Schrödinger's cat, in essence, opens the door to this quantum conundrum. Welcome to the world of quantum physics, where reality is much stranger than fiction. Have you ever thought about what an atom really is? It's a question that has puzzled scientists for centuries and led to the development of some of the most intriguing theories in physics. Traditionally, we've been taught to envision an atom like a mini solar system. Picture a bright, bustling nucleus at the center, where protons and neutrons reside. Around this nucleus, electrons whirl in orbits, much like planets circling the sun. This is called the Bohr model, named after Niels Bohr, who proposed it in the early 20th century. But then, quantum mechanics entered the scene, and things got a lot more, well, wavy. You see, according to quantum theory, atoms aren't just particles. They can also behave like waves. This is known as wave-particle duality. Yes, it sounds a bit outlandish, but stick with me. Imagine a tranquil pond. You toss a pebble in, and ripples spread out from the point of impact. Now, if you were to toss in another pebble close to the first, you'd see the ripples from each pebble interact with each other, creating a complex pattern. This interaction is called interference, and it's a characteristic behavior of waves. Now let's go back to our atom. If an atom were strictly a particle, it would behave like a single pebble hitting the water. One point of impact, one set of ripples. But experiments have shown that atoms can create interference patterns, just like the two pebbles in our pond. This suggests that atoms don't just exist in one point in space, like particles. Instead, they spread out like waves existing in multiple places at once. So what is an atom really? A particle? A wave? Well, it's a bit of both, actually. It's a particle when we're observing it, and it's a wave when we're not. It's a concept that challenges our everyday understanding of the world, but it's one of the fundamental principles that govern the strange and fascinating realm of quantum mechanics. So, an atom can indeed be both a particle and a wave, depending on how you look at it. But how can an atom transform into a wave, you might wonder? Well, welcome to the realm of quantum transformation, where the ordinary laws of physics take a back seat. This is the world where particles can exist in multiple places at once, a state known as superposition. Let's take a closer look. An atom isn't just a particle, but also a wave of probability, a cloud of potential locations. When we're not looking, the atom exists in superposition, its waves spread out. But when we measure it, the wave collapses to a single point. The atom chooses a location. This is a direct outcome of Schrödinger's wave equation, the mathematical backbone of quantum mechanics. It predicts that particles such as atoms can exhibit wave-like properties, transforming between particle and wave states. It's a mind-bending concept, but that's the beauty of quantum mechanics. In the quantum world, atoms have the ability to transform into waves, blurring the line between the tangible and the intangible. Quantum physics might sound like science fiction, but it's very real. It's not just a theory concocted in the minds of scientists, but a tangible part of our universe that has been experimentally verified time and time again. When we delve into the quantum realm, reality as we know it starts to unravel. Particles can exist in multiple places at once, and they can even communicate instantly over vast distances, defying our conventional understanding of space and time. But quantum physics is not just about challenging our perception of reality. It's also about harnessing the power of these strange phenomena. Take quantum computing, for instance. While traditional computers process bits of information one at a time, quantum computers use quantum bits, or qubits, that can process multiple bits simultaneously. This could revolutionize everything from data encryption to drug discovery. So next time you ponder about reality, remember that at the quantum level, things are not as they seem.